Welcome to the i-ROM Model Builder tutorial series. In the last video, a parametric model of a single-axis accelerometer was introduced. In this tutorial we will demonstrate how to run a modal analysis with our model builder. Open the accelerometer example from the projects folder. The single-axis accelerometer from the last video appears on the screen. After generating a solid model, proper mesh settings must be assigned to the spring's prior simulation runs. In the 3D View panel, typical dimensions can be determined with the Coordinate Selection tab. For the nominal case, the length of the connecting bar is 22 micrometers. Timoshenko beam elements with 8 micrometer length are appropriate for the given example in order to create 3 beams in the shortest springs. For this, open the ROM Settings tab. Then assign the maximum mesh divisions to 20 elements, and the spring element size to 8 micrometers to create an even mesh. Click on Build ROM to create a simulation model, and run a modal analysis. In this example the number of modes is set to 15 in order to observe the most interesting eigenfrequencies in the operating range of the sensor. In this example, the first eigenfrequency is about 13.3 kHz. Scale the amplitudes in the Plot Control tab to 18% of the default factor to limit the oscillation range to realistic values. The default amplitude scaling factor is calculated from the relationship of transversal displacements with regard to the model size. Go to the 3D View tab, and start the animation of the first eigenmode. The speed can be controlled with the faster and slower buttons. You can change the model orientation by pressing the Control key, and the right mouse button while moving the mouse in the desired directions. Press Ctrl, and hold the left mouse button to drag the structure in X or Y direction. Or scroll the mouse wheel to zoom in or out. A colored contour plot can be activated for X, Y, and Z displacements. Click on Other Eigenmodes, and observe the structural response. Switch to Z displacements for the out-of-plane modes. Modes 8, 11, and 13 show spring oscillations at higher eigenfrequencies which should be out of the operating range. Eigenvectors, at the mass body center points, at master nodes, or at spring location points, can be listed in our graphical user interface. The numbers indicate modal amplitudes, in operating, and cross-axis directions, and help you to optimize your design. Cross-sectional data of beam elements, the inertial properties of mass bodies, and modal analysis results, are likewise written to result files in the working directory. The next video shows the effects of manufacturing constraints, and electrostatic fields on the modal analysis results. I hope you enjoyed this video, and we see us again.